Welcome back, everyone. This is lesson 2, logic. Logic is the art and science of correct reasoning. In reasoning, propositions are used to advance one's argument. Propositions can be written as mathematical expressions which are evaluated either as true or false. Now, what is a proposition? A proposition is a declarative sentence that is either true or false, but not both. Each proposition is represented by a letter of the English alphabet. If a proposition is true, its truth value is true, denoted by capital T. If it is false, its truth value is false, denoted by capital F. Now, these are examples of propositions. Today is Tuesday, represented by P, proposition P. Jose is smart, represented by proposition Q. And Gina is the secretary of the class, represented by proposition R. Now, the following are examples of statements which are not propositions. Okay. First, please get out. Now, please get out is a statement, but it cannot be evaluated as true or false. Therefore, the statement, please get out, is not a proposition. How are you? That is a statement which is asking somebody how he is. Again, that is not a proposition. Goodbye. Now, goodbye is a greeting. When you greet somebody goodbye, you cannot evaluate that as true or false. Are you sick? That is an interrogative statement or a question. So it cannot be evaluated as true or false. So those are examples of statements which are not propositions. Now, propositions can be combined. When you combine propositions, they are called compound propositions. Now, compound propositions can be classified in the following forms. So, compound propositions are combination of two or more propositions formed by using connectives like and. So, let's say, for example, one proposition is today is Monday, P. Another proposition, Q, we will have our GE2 class. So, you can combine these two using connectives. Okay, the first connective is N. Today is Monday, and we will have our GE2 class. The symbol for N is an inverted V. So this is your proposition P, proposition Q, inverted V. In symbol, you will write it this way. Today is Monday, or we will have our GEC2 class. Or, that is inclusive or. So the symbol for that is V. Either today is Monday, or we will have our GEC2 class. Either or. This is an exclusive or. The symbol for an exclusive or is a circle with a plus inside. Next, if today is Monday, then we will have our GE2 class. This is an example of an implication. If and then. So if you have an if and then, the symbol for that is this right arrow. Today is Monday if and only if we have our GEC2 class. This is an example of what we call as a biconditional statement. If and only if. These are two implications. So represented by two-headed arrow head. Since a proposition is either true or false, so when you combine a proposition, it can either be true or false also. So this is a table showing the truth values. It defines the truth values of compound propositions P and Q. If you are given two propositions and you combine them, you can form four combinations. And what are these combinations? P is true, Q is true. Or P is true, Q is false. Or P is false, Q is true. And last, P and Q are both false. So that is the possible combination for two propositions. Now, you have here the values. This is for conjunction, and this is for inclusive OR, V. This is for exclusive OR, circle with a plus inside. This is for your implication, and this is for your biconditional. Now, it's very easy to remember the truth values of a compound statement. So, for a conjunction N, we call this conjunction N. It will only be true if both propositions P and Q are true. Otherwise, it will be false. So, that's the simple rule. For N, if they are both true, it will be true. Otherwise, false. For an inclusive OR, it will only be false if both P and Q are false. Here. Otherwise, it will be true. That is also the rule for inclusive OR. For exclusive OR, the word is exclusive, meaning to say only one, either P or Q, should be true. So you will only find it here. P is true, Q is false. P is false, Q is true. So, isa lang ang true. So, they are both true. Otherwise, if they are both true, it will be false. If they are both false, it will also be false. For an implication, there are two parts of an implication. This part here is your hypothesis or antecedent, and your Q is your conclusion or consequent. Now, how do you know, or how do you get the truth value of an implication? An implication will only be false if the hypothesis is true and the conclusion is false. So, your implication becomes false. Otherwise, it will be true. So, the rule is true, false, false. For a biconditional statement, a biconditional is a combination of two implications. So, if you have a combination of true, false, or false, true, it will be both false. So, for an biconditional statement, it will only be true if both are true. If both P and Q are true, or if both P and Q are false. Next, negation. If P is a proposition, then the negation of P is not P, represented by tail P or tilde P. So these are the symbols for a negation of P. Below is the table that defines P. Meaning to say, if P is true, then not P is false. Example. Let's take an example. One is handsome. If this is true, then its negation, let's say this is the proper negation. The proper negation of one is handsome is one is not handsome. That's the proper negation. So if this is true, this one should be false. Now, if one is handsome is false, then one is not handsome must be true. Now, let's go to the negation of one is handsome. Although one might say that one is ugly also negates the given proposition, however, it does not always follow that if one is not handsome, he is automatically ugly. So, to be safe, this is the proper negation of one is handsome. The proper negation of one is handsome is one is not handsome. For the next example, you are asked to construct the truth table of a particular implication. This is an implication. So, you have P and Q. So, you form this one, and then you form these two, and then you form now the implication. This one is your antecedent or hypothesis, and this is your conclusion. Now, how do we fill this up? Normally, these two columns are given. So, true, 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 false, false, true, false, false. So, how do we fill this up? So, P then Q. To fill this up, according to our rule, an implication will only be false if P is true and Q is false. P is true, Q is false, so this one is false. Otherwise, it will be true. So, itong tatlo, true siya. Next, this, you have to look at the third column and the second column. This is an N. So, conjunction. The rule for conjunction is the two propositions will only be true if both are true. True, true, true. True, true, true. So these two should be false. Next, let's combine now this one and this. So you have to look at this one. This will be your proposition, the hypothesis, and this will be your conclusion. So you go to the left, from here to here. So this is an implication. According to our implication, this is our hypothesis and this is our conclusion. It will only be false if our hypothesis is true and if our conclusion is false. So, look at our conclusion here. Both true. So, since these are both true, so this will be true. Both false. So, you look at so you do it this way. True, 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 false, true, 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 false, false. This should be false. False, false, true. Oh, this should be interchanged. So this one should be false and this one should be true. Okay? So we'll make a correction for these two. So that should be the proper. So this should be false and this one should be true. There is a typo error here. Next, let's construct the truth table for the next example. P and not P. So P is true, so not P is false. P is false, not P is true. And so it will only be false if both of these are and it will only be true if both of these are true. Since this is one true and one false, so both of them will be false.